Hey guys, this is Mr. C. This is Chapter 8, Lesson 2 on reflections and symmetry. So we talked about our first transformation yesterday. That was a translation, also known as a slide. And this one is reflections, and we'll briefly talk about symmetry as well. So a reflection, let's get started off. What is it? It's a type of transformation that flips a figure over a line. So yesterday the one word we used was slide. Flip is a good way to describe what's happening in a reflection. And the line that it's being flipped over is called the line of reflection. So let's look at this example right here so you can get a visual of what a reflection is and what's happening. We have our original point C and our image C prime. Remember the little prime notation is what lets us know what the image is. And an easy way to figure out what the line of reflection is to look and see where is the original and the image the same distance apart. So I'm going to tell you what the line of reflection is in this example. It's the y-axis, and it's pretty clear with the little pink lines leading up to it. But if you weren't too sure, you could count that C is 1, 2, 3 away from the y-axis, and so is C prime, 1, 2, 3. So both of those points are an equal distance apart from the y-axis, and that's how you can do a reflection, which we're going to do in a second, and you can find out what the line of reflection is. So this y-axis is the line of reflection. And now let's look at an example of actually doing a reflection. If you have graph paper, I would probably use graph paper to be taking notes. I think I said that in class, but in case you forgot, graph paper is going to be a good idea because basically everything we're doing for the next couple lessons is going to require graphing, and graph paper makes that a lot easier. So here's an example. Graph the point A, which is located at 3, 2. So 1, 2, 3, 1, 2. Here is point A. And then graph its image after it is reflected over the x-axis. Alright, so in this example, our x-axis is going to be our line of symmetry. So that means that A and its image, A prime, need to be the same distance apart from that line. So how do I figure out where A prime is going to go? Well, this is going to be my line of symmetry. A is 2 spaces away. So that means A prime needs to also be 2 spaces away. So 1, 2. And there's A prime, the image. It is not too difficult to do a reflection. You just need to know how it works. Pay attention to what your line of, not symmetry, excuse me, line of reflection is. All right. And then you'll be good to go. So again, I'll just recap what just happened. We started with this original point. It was given to us. We were told to reflect it over the x-axis. So here's the x-axis. I determined that A was 2 spaces away. 1, 2. So then I made its image 2 spaces away. 1, 2 on the other side. And then I marked it as A prime because it's the image. And that's all there is to a reflection. So let's try an example. If you want to try without me, then just pause the video and then unpause it and check to see if you're right. So if you are unpausing the video, here it goes. We're graphing the point D, which should be located at -2, 1. Okay, mark it as D. Then graph its image after it is reflected over the y-axis. So this is my y-axis. And it is 2 spaces away, just like the last problem. So then D prime needs to be 2 spaces away. So D prime. And then there is my image, and its new coordinates, D prime, are located at 2, 1. All right, and that would answer the question, name the coordinates of D prime, and also showing the reflection. So hopefully this is making a little bit of sense. Um, let's now look at reflecting an entire shape. Okay, it's the same process as reflecting a point. You're just doing it to more than one point. Okay, I'm going to graph a triangle and we're going to call it BCD. All right. Um, this is an example from the book actually, and the coordinates that we're going to start with for BCD are -2, 1. We'll call that B. C is located at -1, 5. And D is located at -4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And I'll connect points. Now, here's where this example gets a little bit more involved than the last two that we did. Instead of having us reflect this triangle over the y-axis or the x-axis, which I know that you could do, we're going to reflect it through a different line that we need to actually draw and create. So it says reflected through the line that goes through 1, 3, and 1, 0. So if I made a line that passes through those points, it's basically a line that's parallel to the y-axis. It's just one space over. So if that is going to act as my line of reflection, I need to count how many spaces away each point is from that line. I'm going to start with C at the top here. So C is 1, 2 spaces away, which means C prime needs to be 2 spaces away. C prime. Now we'll go to D. D is 1, 2, 3, 4, 5 spaces away from the line that I created. So D prime needs to be 1, 2, 3, 4, 5 spaces away from the line I created. And then to B, 1, 2, 3, 1, 2, 3, 3 spaces away. And now I have B prime. And if I connect them and form my triangle, I have triangle B prime, C prime, D prime. And it was all reflected over this line that I created through the points that were given to me. So a line of reflection can be any line that's given to you. You just have to sometimes graph your own line through the points. So we'll do one more of those because it's a little more involved. All right, triangle EFG has vertices at E, which is at 4, 3. 1, 2, 3, 4, 1, 2, 3. All right, there's E. F, which is at 1, 2, 3, 1. And if you're feeling adventurous and want to do this on your own, and then want to unpause the video and check if you're right, go right ahead. But if you need to see another one, here it is. All right, so there's my original triangle, EFG, at the points that were given. Next, it says to graph the triangle and its image after it is reflected over the x-axis. So I'm going to actually scroll down a little bit because the x-axis is this one, right? That's my y. All right, so let's start with F. It's the closest to it. It's 1 space away, so F prime needs to be 1 space away. G is 1, 2 spaces away from the x-axis, so G prime needs to be 2 spaces away. And then E is 1, 2, 3 spaces away, 1, 2, 3 spaces away, E prime. And there is my new triangle. So reflections, that's all there is to it. Of course, you could reflect any shape you wanted, not just a triangle. I just did triangles because it's the smallest shape and it's a good example to start with. We'll do different ones in class. And you can reflect over any line, whether it's an axis, the y or the x, or a line that you have to draw and create yourself. One important thing to note is that when you're doing a reflection, just like yesterday when we did translations, the shape does not change. It's still a triangle, it's still exactly the same size. All we did is change the position, we flipped it, nothing else. So if you are practicing and you do a reflection that doesn't look like the same shape, it doesn't have the same size, chances are you made a little mistake. So just make sure that the biggest mistake I've seen is people not counting and making sure that each point is the same distance away from the line of reflection. So just be careful on that. We will cover a little bit of symmetry. It's not a new concept to you, I don't think, in class. I'm not going to do that here. So I'm going to just jump right ahead to the summary questions. There's 3 of them again, and I'll scroll down so that you can look at them, write them down in your notebook, and give them a try for tomorrow. If you have questions or you're stuck or I didn't explain something clearly enough, just send me an email. Or if you want, you can just save the question for in class. But do give these a try, and hopefully get a lot of good practice in tomorrow. So here are your questions. All right, I'm gonna have to scroll down a little bit more for question 3. So you might have to pause the video, write these 2 down, and then pause the video and write question 3 down. So here's question 3. And I'll move this out of the way. All right, do your best. Email if you need to. I'll see you tomorrow.